Today we're going to be talking about K2-18b. Now, this planet is 8.7 times the mass of Earth, and it's 2 times the diameter of Earth. It's located about 100 to 120 light years from Earth, and the thing that's kind of striking people, one of the key characteristics is its hydrogen-rich atmosphere. Now, this planet K2-18b also sits at its star's habitable zone. This star is an M-type star and is not too active, and stars like these oftentimes are actually seen as very active. The K2-18b, the position that it's sitting in, they don't really know if it's tidally locked or not. So to me, that's very important, whether this planet is tidally locked, just due to the fact that Hycean worlds are thought to be like 392-ish degrees Fahrenheit, around that. So with it just being parallel and just sitting on the dark side, that allows for there to be like a temperature difference, also creating maybe what is even a termination zone within a Hycean world. That's even more dynamics to add. But it's very, very interesting. These Hycean worlds just being hydrogen rich, having a lot of water on them. This planet in general, K2-18b, is not known whether the mantle is actually rocky or icy, but it's actually believed that it's more so icy. One thing that's actually pretty important, because that all these certain circumstances take you in certain directions. So whether it's icy, that could again also help with some of the life that's in there, because you can find a medium where it is actually not as hot and actually not as cold, to where it might even be the temperature of our oceans here on Earth. You see what I'm saying? At a certain level, in a certain metric, obviously, on the planet. But for even something like that, you definitely need the right circumstances, and that's why they also believe that with the Hycean world, they would be even more formidable planets to be hospitable while even being rogue, or not having a planet to orbit. So just planets like these that are naturally hot in themselves, just due to the chemical composition, just makes it a lot easier for the life, or at least makes it a lot easier when you're dealing with cold temperate environments. But for K2-18b, they did find that they have it has an abundance of methane and carbon dioxide and low ammonia, which also helps in the case of it being a Hycean world. Another signal that they found was what seems to be a biosignature of dimethyl sulfide, which is a molecule that's produced mainly by photoplankton. Dimethyl sulfide is produced by photoplankton and also consumed by photoplankton. Another thing is that it's created also by humans, and it has its own cycle. There's certain places like in the Pacific Ocean where the removal of, this is where they found that dimethyl sulfide is actually consumed by a lot of bacteria, because in the Pacific Ocean there's 3 to about 430 times more removal turnover than there is in the atmosphere. So depending definitely on certain parts of the world that you are, it's definitely dominated by these bacteria that seem to love this compound. And other biosignatures, but have not been found on that planet, let's say, is like something like methyl chloride. And methyl chloride pretty much is also seems to be nice food for bacteria. We can also make that as humans. Anthropogenic sources, which is pretty much human ways of making the chemical. This chemical, methyl chloride, also same thing. It's consumed by bacteria. There's another chemical called carbonyl sulfide, and pretty much this chemical is emitted from oceans, volcanoes, deep sea vents, and it pretty much is a primary energy to certain bacteria. Certain bacteria cannot live without this compound right here, and it plays a key role in the global sulfur cycle. So you see a lot of these things, even it just being there, just because it's there doesn't mean it's also a byproduct of a organism, but it also can be the main product that it needs to survive. These Hycean worlds, once again, are very interesting in themselves, just because finding life, if you're trying to be a advanced civilization and you have to tackle that much gravity being on that planet, your best bet is to be an extra smart civilization and start messing with torsion fields, start messing with things that repel gravity, and do certain things to manipulate the matter around you. Now, for even the life that they seem to find, they've done certain experiments where they've mimicked Hycean worlds, and they've put certain bacteria that even live here on Earth and placed them in the hold. And what they found was, not only do these bacteria actually thrive in these environments, but they actually do create these biosignatures, one, and also two, they also create certain carbon dominated compounds like ammonia, methane, things of that nature were also created in these experiments. But they found that these bacteria, the only way that they could create such compounds was with a medium, and the medium that was used for that bacteria was some kind of yeast. In this case, in this circumstance, they say that for that to work, all that would be needed is the medium of water. So that's why the Hycean world is very, very important. Whether it's rocky interior mantle is put there or not, once again, it just shows the path that it decided to take. Hycean worlds, once again, very, very important when you're trying to find and understand life, when you're trying to understand how many different degrees life can orchestrate, honestly, and even how many different types of life there even can be, not only on Earth but even on other planets. Like, you may not even find one piece of life that's like Earth there on a Hycean planet. Everything may be biologically different, molecularly just strange, but also just have somewhat the same fundamentals. They love methane, they love ammonia, they love this, they love hydrogen, they love molecular hydrogen. It loves to be in water, things of that nature that you can definitely see and definitely gauge. But once again, K218b, the not really yet discovered to be Hycean world, but thought to be a Hycean world, is just one of the, what I would say, stepping stones in the Hycean Expo to try to find and try to understand exactly how these planets generally move, and how these planets actually act, whether it be structurally, chemically, the whole, just understanding certain things like this, because it seems as if when you find these types of planets, Hycean worlds, there's different types of them. There can not only be hot Hycean worlds, but there could also be cold Hycean worlds, which what some people believe is like not really a Neptune, but yeah, like a Neptune. Pretty much, once again, very important discovery. Hopefully it brings to the forefront what we need when it comes to different life on different types of atmospheric planets. Appreciate y'all. We'll see y'all next.